Hello and welcome to the Emmerson Model 505 Part 2. We've got the thing completely recapped and we're getting ready to rock and roll here on the alignment. But before we do, there was a couple things I wanted to talk about briefly. You probably remember me talking about gimmick capacitors a while back in one of my videos, and not to cut these out because you'll end up with problems. Well, lo and behold, let me get a couple of tubes out of the way here so you can see what's going on. This set has got a gimmick capacitor right here in a slightly different form, but that's what it is. Let's see if we can get you in a little bit closer here. We'll lower you down and bring you in right up close and personal to that guy. Oh, what am I caught on? Oh, caught on the scope. Come on, get out of there. There we go. Can you see the intertwine right down here? The green wire and the white wire wrapped around each other. That's a gimmick capacitor. They've tied these two sections together. My suspicion is it's there to neutralize some oscillation in the RF amplifier. And it doesn't show it on the schematic, but I know that's a real deal because I checked the other chassis that I have of the same model and it has the identical wire down there. It isn't like somebody had the tuning cap out and twisted the wires up by accident. That's an actual gimmick capacitor that was put in there intentionally. So we'll move you guys back a little bit, jack you back up in the air. But that caught my attention. It wasn't, like I say, it wasn't on the schematic, but it is present in both radios. And it's things like that you have to watch out for when you're working on these sets. You don't want to go cutting those wires out or altering that, because you could end up with all kinds of problems and not understand why. All of a sudden you've got squealing and howling or some instability of some sort and you don't understand what happened. And it's not the only one that's in this set. Might be clearer on this schematic. The feedback for our oscillator to our control grid right here, you see this dead end? This doesn't go anywhere. They're capacitively coupling one winding, and it's the same thing on this schematic. You see it dead ends right here, doesn't connect. It's an open winding. They're capacitively coupling to these windings with this winding so they have feedback for the oscillator. Now that one's of no worry to you. It's built into the coil. You can't see this. However, if you were to do a resistance check on this oscillator coil, you'd think you had an open winding, and you would, but it's correct. So that's a couple of gotchas. Something I want to touch on, I haven't talked about tools I use for a while, and I know not everybody watches all my videos, and yes, that's the original filter cap still in there. When I was replacing everything, I disconnected that cap. The capacitance is on the money. The leakage is virtually zero, and the ESR reading on that capacitor is an ohm or less on each section. It's virtually a brand new capacitor, and I know somebody's going to get all upset. Oh, it's all dried out. If it was dried out, it wouldn't have low ESR, and it's not leaking. So this is my radio. If this was going to a customer or somebody, you know, if I was passing this on, I'd change that. But that capacitor is absolutely fine. There's no reason not to leave it in there for now. And again, I'm keeping this radio. This is one of the sets that I'll hang on to. I won't sell off at the flea market. Okay, tools. When I'm working on these sets, you've got a lot of these connections in here that have 4, 5, 6 wires going to a tube pin. This is my preferred tool to do my soldering in these radios. Now, I've been doing this for going on 60 years now at this point. And I do have soldering stations. I've got pencil soldering irons, I've got a Heiko, I've got a couple of Wellers. When I'm working on these sets, this is what I go with. This is a Weller model 8200. This one is rated 100 and 140 watts. Instant heat. It's got the capacity to loosen up the solder quickly before the heat travels into other components. It gets the job done. Now you see there's a lot of solder joints on the outside of this radio. In fact, I've got to redo that one. That's not one of mine. I think I'm going to retouch that one up. What I use for those now, and I have 100-watt irons, I've got big 50-watt irons. I don't like plugging those things in and leaving them sitting there cooking on the bench while I'm working on these sets. I use this big bad boy. This is a Weller model D550. This one's 240 and 325 watts. Now these are available on eBay. I've seen them as low as $25 with $10 shipping, and I've seen people asking $75 for these things plus $20 shipping. I mean, it's ridiculous. Be advised, there's more than one D550. There's a D550 that's 200 and 260 watts. You don't want that one. You want to look for the one that's got 240 and 325 watts. And don't worry about the tips. They're expensive and they don't last long. This is number 10 house wiring, and it works like a charm. And in fact, we'll do one joint for you right here. I'm going to drop a little bit of flux there just to make sure it takes. We're going to put this puppy on high heat. It's already starting to come up to temperature, and I'm just going to go right in here. It's got the capacity to make the joint, and you just wait for the metal to warm up and it flows. Done. And it's over there on the bench cooling off. I don't have this 12-pound hunk of iron over there smoking and smoldering, and it's instant heat. It does the job. Boom, finished. And you've got a nice clean solder joint. The solder's flowed, you know, it's taken to the chassis. They do a beautiful job. And again, that's the model D550, but make sure you look for the 240 325 watt version and use number 10 house wiring for your tips. You can, you know, a 5-foot length of number 10 2 with a ground, and you got enough tips to take care of you for the next 5 years for virtually free. Okay, this thing's up and running, I hope. Now that it's been recapped, we'll turn it on and find out how I did. Are we hero or zero at this point? Oh, a couple other things. As I was working on this set, I was looking, you know, into it. There's no screw in here in this IF transformer, and I had a heart attack for a minute. And then I looked at the schematic, and sure enough, there's no screw. There's only one adjustment on that transformer. It's this one right here. You see there's an adjustment on this side of it, nothing on this side of it. And just to verify that, I looked at the other chassis, and sure enough, there's no screw on the one in the other chassis either. I think that's the first time I've seen a missing screw on an IF transformer. There's only 3 adjustments on this. Of course, we have adjustments for the antenna, the oscillator, and the RF amplifier. It's got a tuned RF amplifier, and that's why this set's so nice and sensitive. Excuse me. The older I get, the more indigestion I get. Let's see. Oh, I know what else. Before we turn this thing on, if you take a look at the schematic here, these are our batteries, our A and our B batteries. We'll take a look at this line right here, this plus line for the battery. It's connected directly to our power supply. I forgot to mention this in the first video. And when the power switch is on, we have a path for our filament circuit would pass through the 3Q4, and normally this would be dead end because the plug's not here, but it means the battery connector is live on this side. So you have to be careful with all of these plugs. I have a little piece of rubber pressed over the B plus one because that's going to be live at 90 plus volts when the radio is turned on. And we don't want to short circuit our heater supply, so I've got a little piece of plastic pushed over the pin on that so it doesn't get bumped up against the chassis or dragged over one of these ground connections on here, and you don't end up blowing up the filaments or knocking yourself on the floor because you grabbed a hold of the hot 90 volts. Totally forgot to mention that on the first video. So just be aware, on a lot of these sets, when they're turned on, these battery connectors are going to be live, and that's probably why they chopped them out of the other radio, but I'm going to leave them in here. One of these days I might get around to building some battery packs for this. Which brings up another thing. I mentioned last video that these sets are virtually instant on when they're on batteries. So we'll try and experiment. I'll hook up my Heathkit supply, set it up to 90 volts so that we have a B battery, and I'll use one of my other power supplies to give us the 9 volts for the A battery, and it's 9 volts because they have tubes in series and some resistors in there to break up the voltage, even though they're 1.5 tubes. But we'll hook up the correct voltages to the battery connectors, and I'll demonstrate how quickly these 1 volt tubes warm up. It's virtually instant when you turn these sets on. And again, this is going to come up slow because when we turn it on, the rectifier and the amplifier in this tube have to warm up. And once the rectifier starts producing B plus and the amplifier starts conducting, its cathode drop is what powers the 1 volt tubes in the AC mode. And we saw that, you know, that's what we showed you on Nerd's Corner, was how the cathode dropping resistor develops the voltage for our tube string using the 117N7. And again, I don't know why they don't do this on more sets. It's so convenient, and you don't have all these resistors burning heat into the set. Okay, let's turn it on. And let's see how long this thing takes to warm up. It's drawing 100 milliamperes. The tube's coming up to temperature. And then it'll go back up when the amplifier starts to draw current. We're down to 90 milliamps and back up to 100 milliamperes, 110, 130.
Emission of vaccine. I don't know if you know this, but when it became clear that these MR...
Oh, camera supply is on. Something else I've noticed on these battery sets, and it's fairly common, I've seen this on a lot of them, the last eighth of a turn on these volume controls doesn't do anything. Excuse me. Ah. The last eighth of a turn doesn't turn it down. You've still got volume there, or sound there, no matter what. And it's not a bad pot, it's not noisy, it's not open on that section. It's just
seems to me
that last eighth of a turn doesn't do anything. And I suspect, because I've seen it in so many of these sets, I suspect that was an intentional design feature. Because these sets ran on battery. And it's common when someone says something to you or starts talking to you to, I'm going to shut it off while I'm talking about this. If this was on battery and someone started talking to you and you turned the volume down to have a quick conversation, you might forget the thing was on and walk away from it and kill your batteries. It's going to be impossible to forget that it's on if the volume doesn't go all the way down. So I suspect they did that on purpose. I've seen it in so many of these battery sets. I think that it was just something they did so you didn't forget. I could be wrong, but after seeing it in multiple sets to do this. Okay, I'm going to set up the signal generator for 262 kilohertz. We'll use this guy up here. We're going to have some fan noise along with everything. Oh, I'm going to turn off the camera here for a second so that I can unplug the power supply. Okay. We're back on battery. Oops. Let's hope the batteries have a good charge in them. Blah, 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 blah. Frequency 262 kilohertz. And we're about 500 microvolts. You should be able to hear that, I think. They want the tuning capacitor all the way open. We'll turn on our time-based voltmeter over here because it's right in front of us and it's easy to use. Try to make sure we don't have too much of a reflection on there. Alright, we've got a ground. They want us to connect to the front section of the variable capacitor. So we will connect to the front section of the variable cap and ground. And I'm not hearing anything. So we'll hook up our time-based voltmeter here. Okay, that doesn't look very good. Why do we have such a crappy... Oh, try that. Okay, something else is buzzy. Not that one, it's that one. So we'll leave that light off so we don't have to listen to that going buzz, 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 and we'll turn up the amplitude here. Oh, no wonder there's no signal. I do have the modulation on. .262 kilohertz. But I'm not hearing any modulation. I'm hearing some blocking. This thing was just about dead on. It's just not enough signal here, I guess. There we go. It was virtually dead on the money. Of course, we kind of suspected that because the set was so sensitive. Yeah, this could have gone without an alignment easily. We're really not making any improvement there. Okay, that's step one. Step two, 1425 kilohertz. High side of the stator on the rear section of the variable. And 1425. So we'll put this about 1425, and we'll put 1425 kilohertz. 1450. I don't even know if that's worth messing with on this dial. We can move it a little bit, I guess. We're going to adjust A4 and A5. A4 and A5, I think, are the two front sections. A4 and A5 are the two front sections. I should use a real tuning tool for that because it's going to be on the capacitors that are on the top of the cap here. That was out. Turn our signal generator down. That takes care of our oscillator and our RF amplifier. And the last thing we have to do go to 600 kilohertz. 600 kilohertz. And we go 600 kilohertz frequency, 600 kilohertz, and adjust A6. Okay. Brought that in. And what that is, we're adjusting the low end with this trimmer, or excuse me, with this trimmer, and the high end with this trimmer. We've got one, this trimmer is associated with the oscillator coil, this one's associated with the tuning capacitor. So we'll go back and forth a couple of times and net this thing in. Actually, instead of 1425, I'll go to 1400 so I can put it right on the mark. Oh, it's right there. Amazing, right on the money. Because this set has both upper and lower, we can net this thing right in. So if I go back to 600 kilohertz, it should be right on the 60. And there it is. The next step we have to do is go back to, oh no, we leave it on 600. And we adjust actually connect signal generator coil. Oh, they're telling us to adjust the antenna using A7, the one on the back there. But I need a loop antenna. Let me go get a loop antenna so that we can feed some signal off the air, so to speak. Okay, we've got our loop antenna in the back. I can't do it at 600. We have a very strong station at 610 that's just blasting right in here. So we're going to do it at 550 kilohertz. Come on. And that pretty much does it. turn off the output here. RF off. Let's see what we got.
Built bars are low carb, low calorie, low fat, low sugar, high in protein, and they're delicious.
610.
Set up that we elect our district attorney.
Much needed assistance.
These people, their job Constitution.
In particular, Texas. Ayanna Presley said people they were talking about.
Why? I can't get over the tracking on this set. It's right on the money. That's 1370, just below 1400.
머리에 떠오르는 생각들을 줘.
Honey, you say, hey, wait. Hey, I mean, where did
This is always about 1-800-5.
you with us and telling us the truth?
Thanks so much for having me.
800-9.
Number 2.
Getting Omicron, fully vaccinated.
Alright, I am just tickled pink with this set. I had a feeling it was going to be a good performer when I saw the schematic before I bought the radio, and I am very pleased to say it is. It's a great little performer. It's very sensitive. So we're going to let everything cool down here, and I'm going to hook up some voltages and emulate batteries, and I haven't tried this, so I don't know if there's going to be some interaction between the power supplies. We could end up with a lot of hum, but let's see what happens. Let me get set up. I'll get the voltages set up and we'll turn it on and see how it goes. Alright, I've got the Heathkit supply over here set for 90 volts, and I've got another supply. You probably can't see it, the light's in the way. Another supply up there that's set for our 9 volt A voltage. They call for a B battery of 90 and an A battery of 9. And we have to put our plug with the key on it, has to plug in to this connector here so that we have our ground connection for our 2 batteries. So we'll plug this into the back. And this is keyed so it can only go in one way. So now we have our ground for our batteries so that they're active, quote unquote. And let's see if I can do this without knocking myself off on the floor. So our A battery connection here this is our plus. It's marked right on that plug, and there would be 2 45 volt batteries in series. So I have another connector which will have our minus on it. This white wire connects between the 2 of them, puts the 2 batteries in series. So we have, and we want to make sure we put it on the A and B battery and not on the filament battery, because we would end up blowing the tube filaments if we get the 90 volts. And this connector, yes, this connector is marked B battery. I just wanted to make sure. That would be a bad, sad day. And this one is marked B battery minus. So that goes on there. Now I want to segregate my A battery away from my B battery here. Let me untangle this. We don't want any disasters. The B plus isn't on at the moment. I've got to throw another switch to energize that. Okay, according to my schematic, the yellow wire is A+. So my A+ goes on the yellow, and my A- goes on the black. What am I sitting on? Why is the set not sitting flat? Oh, the plug. The little tang on the plug is sticking out. That's alright. So we have A, B. I'm going to go up here. We will turn on. We'll probably see a blink. Is the caps charged? Nope. Oh, that's right. It goes through the switch. We have another switch closure to make. Okay. Let's see what happens when we turn on the radio.
Pro-vaccine advocates cannot, in good conscience.
See how quick that came on? Those heaters are gossamer thin. They have no thermal mass to speak of, because they're designed to run on basically flashlight batteries. They draw 50 milliamperes. You figure the average flashlight lamp and a 3-volt, 2-cell D-cell flashlight is about 275 milliamperes when the flashlight's turned on. And you'll get what, 4-6 hours, maybe 4 hours at least, probably, out of a couple of D cells before they really start to dim down. So if you had one of those sets that ran on a single D cell, you'd be running 4 tubes. I've seen schematics with 4 tubes. They're real basic sets, but they only have 4 tubes drawing 50 milliamperes a piece. That's 200 milliamperes, so it's drawing less than a flashlight bulb. So those filaments are really, really thin.
Just tell people what to
Turns on just like a transistor radio, just instant.
to take into account their unique medical history, their current medical condition, and then talk to the doctor or doctors and medical professionals they trust, because I'm not qualified.
We're drawing 10 milliamperes of B+, and let's see how many milliamperes of A. We're drawing about 40 milliamperes off the batteries. So the A battery. So the A battery would last a long time.
For antibodies, there's all these other mitigation strategies that the administration should be focusing on instead of this power.
So there you have it. An AC/DC Emmerson 505. And I'll get this thing cleaned up and probably take a quick picture of it and just show you in another video. I won't draw this one out. When I get it cleaned up and I get it put back together, and this will become one of my favorite sets. I love this little set.
You know, I have always been a constitutionalist and a federalist.
Okay, I just couldn't resist. I had to put it in the case. The dent came out. There's a tiny one down here, but I'm not going to bother with it.
Here we go again.
The window cleaned up nicely.
Spent 99 weeks at #1 on Billboard's top.
This is a survivor. I think I'll keep it just like it is. It's like when you find that barn find car that, you know, only needs a little bit of love and attention to get going.
She gave due props. She retweeted a Taylor Swift fan post about the new record and...
Back 3 now to the park.
Down by 14 to 21 points, but
they were made up of seemingly ordinary.
You know, you get back, okay, if I'm having a fabulous growth stock, that because fabulous inventiveness and they're doing one.
I'm the radio mechanic. Hope somebody found that entertaining and a little bit informative. I am going to start adding a reading list down below in the doobly-doo and start putting in, when I find parts like the vibrator, I'm going to start putting the sources of some of those rare parts down in the doobly-doo. So when you give me a thumbs up, I hope you'll go down and click on the more thing, and they should be able to find the reading list that I suggest you have. And we'll start adding as we find some sources. Like if I find a source for the speakers, you've probably seen the video where I had that rant. We'll put that information in there so that the next person that comes along doesn't have to search and search and search. He'll be able to go right down there, or you'll be able to go right down there and say, I order my vibrators, electronic solid-state vibrators from here, and I get my speakers from this guy. See you soon. Take care. Bye now.